simple question. One, what should be the name of
Okay, we lost him.
the file? Like what we've been doing in ALS, you create a repo, you create a directory under it. So I want to know if we are following the same sequence for this particular project, and if it is, what should be the name of maybe the directory, and then for the printf function, the first printf function for test 0 and test 1, what should be the name of the file?
Did I
Okay,
answer that or do you want to?
okay. Just so we can. Okay, we'll answer these questions later, but just a short response, a brief response. It's your choice, okay? It's your choice. Name your function what you want to name it. Name your function what you want to name it. But the name you're looking for is that while you compile all your functions together, you should be able to produce an executable, the executable that they want, right? And do it. Aisha, Aisha, go ahead, please.
Okay. So basically, you're supposed to name your file. You can name your files anything you want it to. They're trying to test that everything you have been doing so far, you have you have been following. Yes, the way they do it normally, you create a directory inside the repo and then they'll give you the name of the files and blah blah blah. But for this project, they are allowing you to name your files whatever you want them to, your functions, anything you want, as long as the name of your repository must be printf and the name of your printf function should follow this their protocol that they gave. So it should be underscore printf also. And everything you are pushing, make sure you do not push your main.c file. Push everything except the main.c file so that when they compile everything in that repository, all .c files in that repository, you should give them an executable that they can run and
Okay.
it will work like the print function. So you can name your files anything you want. Is that helpful?
Okay. Sorry, I understand what you're saying. Okay. Now, the from what you're saying now, we should name the file like underscore printf dot c. That is what we should name the file. But
If you want,
the
yes.
okay, if we want to. But when you
Yes.
run GC, sorry, I don't know if I'm going too far because I read through the requirements and everything, and I noticed that where you have the GCC under the test file, after the GCC, where you have the GCC, there was no inclusion of the name of the file.
Yes. All .c files. They
I
are
guess
going
I will
to
ask this question later on when you are done.
okay. Yes, please. Thank you.
Because to test that same file, after the compiler, to test it, you do dot slash printf. So if the name of my file is underscore printf, how do I now reconcile it with the test file that they have there? That is actually where my question is coming from.
All right. Okay. We'll answer those questions later on in this section. Or you can tag either of us, any learning ambassador, on Slack, and we will respond to you. Okay.
Okay, top man, thank you very
Sorry.
much.
Thank you.
We'll
All
answer
right.
at the end of the
Please.
call.
The noise. This is getting plenty. Okay. Please be another bit of us. All right. Let's begin. Let's start from the known to the unknown. I want to deal with. I want to expose what um, you can call the secrets of printf. Okay. Now you want to rewrite printf. You want to implement your own printf, emulating the standard library printf. You need to understand what this printf is, how it works, and what it does. Now, the first skill probably that you want to acquire is collaboration. How to collaborate on a project. I have a playlist on YouTube that teaches that, so I decided that wouldn't do that for this section. So it just where's that playlist? Okay, here it is. So you can go and learn how can, oh no, I didn't ask you to play. I'm just silly. How can two persons work in the same repository belonging to one person? I'm sure you want to learn, you want to understand how that works. So this playlist can help you. This first video here can help you. Don't misbehave now, you. From there, okay. So for now, let's just expose certain things that may not make complete sense to you, but they are needed. They are needed. How does this printf work? You recall that at some point in this program, you used something like underscore putka, an emulation of the standard library putka. So how was that even possible? They were trying, I mean, it became possible for you to do without putka itself. Then what is putka? What does putka do? You know what putka does? Makes you want to makes you able to compare it to this underscore putka. How well do they relate? How accurately was it emulated? Now I'm not going to go deep into that, but let's see what putka does first or for, and then see what underscore putka does. Now putka prints only a single character. When we say single character, what do we mean? Meaning just one thing. One, it could be an alphabet, it could be a symbol, it could be a number, but the moment it is enclosed within single quote, it's a character, right? Except it's a special character. A special character can have two characters as one character. I mean, for example, the popular /n for new line, it becomes a character. It's seen as a character, right? So putka prints only a character. It does not print more than one character. Let's see. Return 0, and then I save it. I'm going to exit this. I'm going to compile it. GCC. I named the file example.c, right? So I'll say, let me call it main. I choose to call it executive main. Okay, compile with that error. So let's run the main. Okay, now it printed arrow here. You can see the arrow here, and because it prints a single character at a time, I could not ask it to print a new line without. The only way I could do that is to get this stuff. I'll copy this stuff from here and then have it pasted here, and then change this to sorry, the new line character. Come on, /n, and then if I save this and minimize again and compile this again and run it again, it becomes obvious that R, the letter R, was printed. I hope this is visible enough. Let me zoom in some more. Okay, now let's now do what will happen if I remove this particular header file here. Let me take it off, and then okay, let me just put an empty space there, and then come on. Okay, let me take it off. What will happen if I begin from here? Now let's find out. If I try to compile this, there's trouble. They don't know what putka is, because its function is defined in that standard library. I mean, the header file that has something to do with it is the stdio.h. Please, Moses, lower your hand so I don't get distracted. So that's why it has to be there. The only way you will have it not there is to write your own, define your own function. So if I go here and say, okay, you know this, you should be familiar with this. I say I have a function that returns integer. Its name is underscore putka, and it takes as argument a single character. Of course, C can be Z, can be X, can be anything, right? Then I say what this function does is it uses the function write, and it writes to the standard. Okay, Aisha, please watch the income messages in case someone is addressing me there. So it takes one. I don't want to explain this right now, but this actually means where is this streaming to. One stands for I think that's the first argument, right? This is a standard output. 0 for standard input, 1 for standard output, 2 for standard error. Please don't bother if you don't know what that is now. Don't Don't panic, okay? Don't panic. These are things, people are doing these things. You can do it. So the next thing I want to do is the address of X. You know what this means? You did this in pointer, right? Address of X. So to the address of X, right? Get what is there, stream it, and stream only one of it. Stream only one of it. Okay. This is supposed to be my return value. So I don't need to. I need to enclose all of this in the parentheses that belongs to um, return. So I say return, and now put all of this in the parentheses. Okay. I couldn't have defined this as pushka because it is illegal to use a keyword in C, to define your own function. So I'll now go and call underscore putka. Let's see if there's no error in this code, it should do exactly what putka does. Let's now save. And I'm going to minimize. I'm going to compile again. As an error somewhere. Right. Okay, who has sent the error? What's the matter?
The curly braces. You didn't enclose the curly braces for the putka.
Great one. Alright, so there should be a closing curly brace on line 4 here. And then save it. Let's try again and see whether we get some more error. By the way, I want to clear this screen so it doesn't get too crowded. And I'm going to compile again. One more error. So what is the error now? Dun-dun.
The right function. I don't know. Is it seen it as it is undeclared? It said the function right has not been declared.
Thank you very much.
So it has to be declared from another function, from another header file.
Which is?
I don't know.
Okay. Alright, so that's where you use the man page, right? So that's actually
So
what? Someone talking? unistd.h. So right now we are dealing without stdio.h because we've seen something in unistd.h that we could manipulate to produce its result. Now let's see which error we'll get this time again. We want to compile. Oh, no more errors. Alright, so let's run the file main again and see what happens. So it's doing exactly what putka underscore putka what putka does, right? This way we will produce our own underscore. They are not exactly the same. There are differences, but let me not go too deep into that. Now let's talk about the printf that I want to rewrite. I just rewrote putka right now before us, and of course it's not my code. It's something we met in LX, right? Someone did that a long time ago, and we've been using it. We used it at some point. So the person understood how this guy in putka work before he or she did that. It feels like it was a he. What do you think? Okay. Secrets of printf. First, you've got to understand that every time you're working with printf, most times it looks okay. Let me not tap out with this file. Let me create another file. Let me call this one printf. Let's see. Okay. First of all, when you want to use printf, it comes from this. Do the man page, like do man printf. Don't take this for granted. Read the description. Read about return value. It will help you. It will inform you a lot. And don't panic. Don't be hoping that after reading the manual you can now write your printf. You have to give it time. You have to consume a lot of materials. Work with your pairs. Okay. I'm declaring the main function. Let me leave this comment up here. Alright, how does printf works? How does it work? What is it about printf? If I want to reproduce it, what am I going to implement? Let's begin from here. Most times you see that printf is just giving a string. What is a string? Any piece of text within double quotes in C is a string, right? It could be anything from A to B. This is a string. Let's find out that there's no special character inside there, right? So let's find that. I'm going to save this and let's run it. Of course, I want to have a new line character at the end here. Let's see how this works. So I'm going to compile it. GCC, the name of the file is printf. Let me name it printf as well. Printf. Okay, so let's run our printf. So it prints that thing I gave it, but it did not print the last one. So the first thing to note is that printf can print any string either directly or indirectly through when you pass the container to it as okay, let me not go there first. It can print strings for the most. In most cases, it prints strings, as most of the printf you see strings. Now note that some characters in printf are special. Example is this one. It didn't print out. Did you observe? Backward slash n, the last thing didn't print out. Maybe I should use something that makes sense and not some randomly generated strings. Maybe I should just use only my name, right? So I say Topman Paul-Dike. Save this, minimize, compile it again, and run it this time. So it printed only my name. It didn't print the backward slash n. I'm sure that thing is not strange to most of us here. It has special characters. It could be, let's say, I wanted to write more. Let's say my age, and I put this and put backward slash t. This one is for tab, and then I say, what's my age again, please? 230 years old. Okay. And now come here, compile this again. If I run it again, you can see that. You can see that. Oh, I didn't put the last. No, I don't like this. It's looking ugly. Put new line. Add a new line here. Compile again. Now run it. You see that? This is what the backward slash t is doing. This is what the backward slash n did, and this is what the backward slash n did. Just move this to a new line. So that's it. Some characters are special. You put them there, they are not ordinary. Characters like let me go to my whiteboard now. Because of time, I'll hasten up. Characters like, who want to give me examples of such characters, please? Characters that when you put them in printf, they are special. They're not like any other character. What is this? Away. Unmute at random. Just unmute and be shouting. If you know them. They don't just print like string. If you put them, they mean something. They carry out an action. Come on, say something. Moses, your hand is still. Asterisk. Do I know what asterisk is? Like this. Okay, she says asterisk is special. Yeah, call some more. Hashtag, like this. Okay.
So what did you ask? My transmission is breaking.
What did you say?
Percent.
Okay, I asked for those characters that are special in printf. If you put them, they don't print like ordinary character. So I say name them.
Okay, we have modulo.
Modulo. Yes.
Backslash.
One. Don't mention more than two. Sorry, don't mention more than one.
Don't mention more than two. Sorry, don't mention more than one.
Right? Who has not talked? Do we have some more? Okay, let's go and try this character and see whether they are special. As you said. So let me put. Let's begin with star. Asterisk rather. And then followed by ash. Now let me put ash after my surname. So we expect that it should, if it's special, it should do something. It should not print like an ordinary character. It should do something, carry out some action. Okay. What else do we have there? We have modulo. So let's put modulo. Okay, let me not confuse us. Let's stop here. Let's go and try these two first. So I will save it, and I will minimize, and I will compile this again, and I will run it again. You can see that there's nothing special about those things. They printed like ordinary characters. Alright, let's now try the other two. I will change the asterisk to modulo, and I will change this ash to, no, I won't put it there. Let me put backward slash somewhere at the beginning. Yeah, backward slash at the beginning of T. So, okay, let me even put a space. Backward slash space T. All right. Now let's minimize this and compile again. See, now it wouldn't even compile, and it's complaining. character P. You know why? This guy does something special. Now let's even confirm whether this guy is really special. You can see he printed. No, he didn't print. Sorry. Let me go and take it off. So now that we've confirmed that modulo is special, let's take it off and try again and see. It refuses to compile as well. What is the problem? 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 Okay, it says 040 sequence. Escape. Okay. So it shows that this guy is special as well. Great. So it means you know several of them. You're the one that gave me these things now. It means you know several of them. So you want to pay attention to them and see what are those things that when you put them in printf, they don't print like ordinary character. That's one. And then you need to know that some characters are ordinary, but when you add something to them, they become special. Example is N. N is ordinary. Topman has N and it printed like an ordinary character, but the moment you add backward slash here, it ceases to be ordinary. There are characters like that. I just did T as well. T is supposed to be ordinary, but the moment you add backward slash, it becomes something else that is not ordinary. It becomes not an ordinary character. Okay, and then you need to understand the veridic nature of printf. When I say veridic, is how that when you define an argument, when you call a function, rather, and let's just say, I would put as a comment, this is a function. You write the name of your function. When you're calling that function, what you put inside the parentheses is called argument. So if you put only one thing like this, that is it. It means you're giving one argument. Once you see a comma, it means you want to introduce another argument. Okay? For example, if you wrote a function that adds two numbers together and you call the name of the function is add, when you call it and you say add and 4, 2, you've just given it two arguments to work on. Right? But for printf, have you noticed that sometimes you can have plenty of comma? There's no limit to the number of comma you can have. There's no limit to the number. Please lower your hand if you're not talking to me. Moses, please lower your hand so I don't get distracted. Okay, so but printf has this capacity. Let me make this string simpler now, just only my name. It has the capacity to take more than one argument. Here you put comma, and put more, put comma and put more. And for such to happen, there has to be something called format specifier. Format specifier are those things that you must have been using before now, that are used to dictate, instruct, determine the format in which a data should be printed. It should be printed rather. So we have this. We have these and several of them that you should be familiar with. Okay. Now, once you put the format specifier and say this thing should be printed in this format, then you go to the printf after the comma. That means you're passing an extra argument. You're passing more arguments. So do this thing. There are other cases as well, where you have two arguments, but you don't have two format specifiers. We may get there if time permits. I'm watching the time now. The time is almost. Okay, that's why I will now say, if I put %C here, for example, it expects the second argument to be a character. Right? So let's see whether this works. I'm going to try this screen first of all. Compile this. So you compiled that error. Let's run it now. Right? You. So you printed A. Now, if I now say, put a space here and say %S, it expects another argument here that has to be a string. If you don't want error, let's call this PLD section and close the string, and then minimize. You can see a period section. This one was printed by %C and so printed by %S. If I do the same thing, if I give it %I, let's say %I or %D, which in the case of printf function are the same, they do the same thing, and I need to add another function, another argument here. Let's say 2, 3, 4, and then this time it is not enclosed within single quotes. It is not as well enclosed in double quotes because they are numbers. It's an integer, right? So here we go. Let's compile again and let's run again. You can see that. I may as well go. Let me do the fourth one. And because of time, I think I should stop here. I can as well go here and say, give me is not percentage f. When I say percentage f, it's expecting me to give it a kind of value here. That must be a float. That's why you know that 234 is not the same thing as 234.0 in C programming, right? So let me save this, minimize, compile again, and run the file again. You can see now it's giving. I wrote only 1 0. It's giving me plenty of zeros to 6 decimal places. So this is 3 zeros plus 3 other zeros, 6 decimal places. How do I control that? Let's have talk about precision. This one is the things you do on the advanced task, right? Determining the precision, the width, and all of those. Because of time, please, I'm going to stop here. But let me just do something with precision. If I wanted this stuff to print only 2 decimal places, right? All I need to do is to come and put something here as a point 2 and save it, and that'll be it. Compile again, print again. So now it says 234.00. So I'm just trying to say printf can perform beyond the normal. You know about escape sequence, right? Beyond the usual thing, the daily use that many people use it, things that many people use it for. You can perform advanced tasks and things that printf does that you probably have not performed with printf. Now all of this stuff, you might as well be aware that we can have them inside the variable and not have the variables here. So I encourage you to read about this printf, know what it does and how it does what it does, and then read about the individual functions given to you to learn. Consult the man page, just learn with pairs so that you know what you are facing, and then face it. Stop panicking. If you find yourself confused, it's normal. Everyone in the tech space gets confused almost on a daily basis. Yeah. So I'm going to stop here. Let you ask questions, and we have Aisha in the house ready to take all your questions. Thank you very much.
Guys, kindly, okay. Please fill the feedback form in the chat. And I also shared the link to Topman's playlist to guide you on how to go about it if you're still stuck. Then Moses, you can ask your question. Thank you, Topman.
Okay, good evening, everyone. My question is this: in the writing of this point, sorry, I'm just asking a lot of questions.
It's no problem.
Should we use which is preferable? Like I went through the requirement. We're supposed to use write function, but from my understanding, from what I've understood, I know write function is a bit. Sorry, where I am is a bit noisy. Sorry, please. Sorry about that. What I understand is the picture function that we use.
Guys, before leaving, sorry, please fill the feedback form.
Has write function in it.
Sorry, go ahead. Sorry, continue.
The pusher function we are using has a write function in it. So would it be fair to just use only write function without the pusher or the pusher function, like which is recommended?
You can use either of them, whichever you are more comfortable with. I think both of them work fine, especially since the pusher uses write, so you end up using write. If you want, you can use the write directly and not use the char at all, but you can use the code char as long as the code char you are using is yours, not the built-in function. You can use either of them, whichever one you're comfortable with.
Okay, thank you very
Okay.
much for that.
No problem. Yes, go ahead, protocol.
Please, I would like to ask a question about the petty code style. Like, is there a recommended number of lines we are to code in the, let's say,
Yes, in a function.
text editor? Because recently I've been doing some typing on my function, and it's telling me that the number of lines is more than 40.
Yes, Betty has that restriction. Your functions cannot be more than 40 lines. So you have to try to make your codes compact. Try to use the simplest way to solve a problem. Don't go the long way. Like that, Betty does not allow you to write a function more than 40 lines. So you have to work on that.
Oh, okay. So I can create separate files to put my function in, right?
Yes, you can. As long as they're all .c files, you can create as many files as you need. But the function should not be more than 40 lines. Go
Okay.
ahead, Stephanie. Is that okay? Is that all?
Yes.
Okay.
Okay. Good evening.
Good evening.
Okay, so my question is more for clarity because it's related to Moses' question. And
Okay.
my question is, can we go ahead to create our own podcast functions then and use it?
Yes, you can.
All right. Thank you very much.
You're welcome. Any more questions?
Yes, one more question. I'm still coming
Okay.
back to what the question I asked, the first question I asked earlier on. How
Okay.
do we separate these names? Okay, let me be a bit explicit so that you understand where I'm coming from. I've actually dived through this project, and I've been able to write this project using if else, switch case, and what was the third one? One of the other functions. I got the idea from JavaScript actually. Now, when I was done writing the program,
Yeah.
I compiled it using GCC. I compiled using GCC. It's converting the test file in the project format. That's ./printf. I was getting
Yeah.
this response that there is no printf directory or file because the name of the file name I used was _printf.c.
Okay. What?
Instead of when I did the GCC, I got another executable file with the name a.out. So when I tested that ./a.out that was created when I compile,
So
it gave me
what
my
you have
results.
to
My question now is
continue. Yes.
file they are giving. Hello? That's file. When I compile the file, and it's giving me another executable file, different from the one I should use, the one that was stipulated here. What do I now do? Because I know they'll be looking at my the file I'm going to push to the repos. So I don't know. That is actually where my concern is coming from.
What you have to understand is that the executable file is not determined by what you name your .c files. When you do GCC aesthetic, like when you GCC all your .c files without specifying the name of the executable. I don't know if you have noticed in some of the projects when they are compiling to GCC, they would specify like GCC, they'll list the name of your files and use this flag -o and then the name of an executable like A or something. If you want the name of your
Yes,
executable to be
yes.
printf, you would GCC
Minus O,
yes
the name of the
printf.
file.
So it doesn't
Yes.
matter. They are just when this the parts where they are showing you command they are going to use to run your file is just to let you know that they are going to run your files with all those warnings, so that you can also test with the warnings, those W error and so on. So that the name of your executable is a.out, not a problem. Okay, if you want it to be printf, just use the -o flag and name it printf and run your files with /printf. But it's not dependent on the name of your files, your .c files. Do you get what I'm trying to say?
Yes, I get it. Then let me now bother you. Yes, I got that. Let me now bother you on the last question before I finally don't mind me, please.
It's okay. It's okay.
I just want to be clear before diving into this program, like into this project completely. I've just been test running a lot of things. I'm not really had. Okay, for this is actually more like a personal question. The individual test, test 0, test 1, which are the mandatory, then the other 14. Are we expected to create different files for each test?
You see, the whole project, everything is one big project. So create as many files as you want.
Into one.
Just make sure, yes. Just make sure that
compiled it work. I didn't use checker to check it because I know my project is not even near everything. I was just testing it to see a suitable thing to do.
Okay. Just the whole project is one big project, so you can create as many files as you want. Just make sure that when you GCC all .c files, your executable works for all the tasks. So you are supposed to be improving on what you have written before. If for task 0 you had just 3 files and you needed to include some more functions, and let's say those files are already full because you can't have more than 5 functions in a file. You can create more files, but just make sure that GCC all the C files will not spoil everything you have done before. Okay, so create as many files as you want. Treat the whole thing as one big project, and as you keep advancing, be testing the things you have done before to make sure you have not stopped with what you have done before. You are just supposed to keep improving on what you are writing. They are not separate files for different tasks.
Okay.
Is that good? Does that answer your question? Does that answer your question? Okay. Please fill the feedback form, guys, in the channel.
Yeah,
And I
think
also
I understand.
shared
Thank you very much.
a link to Topman's playlist.
Not really, but I think I get where you are coming from. If I decide to dive into it now, become very explicit about it.
I can't hear you anymore.
I don't know if it's permitted actually. Like I'm trying to start sharing what I've already done in my own project. I don't know if that is right.
You can just
so let me just leave it at that and just go and test run what you have advised me to do and see. Okay, I'll do that. Thank you very much.
You're welcome. Please fill the feedback form. Thank you.